Welcome back. Today I'm going to be going over this SAT system of equations question. Um, and once again, thanks to Anico.ai for providing this specific question in their free resources tab. But before I start explaining this problem, right, both using math, like the mathematical way and Desmos, please give it a try. All right, so here we have system of equations where there's only one intersection, right? That's what I've highlighted here. There's only one point that they intersect at, and they're asking us to find the value of the x coordinate of that point, right? So this right here. How do we find that? There's two ways to do this, right? The first way, you can actually solve for p, right? What do I mean by that? Well, you know there's only one point in the system, so set these equal to each other. And you can do that, right? Because both of them have that y equals. So when you get that, move everything to one side. Okay, and now, right, you'll notice that this is in the form of a quadratic equation, right, where we have ax squared plus bx plus c equals 0. Now, why is this important? Well, because we're told that there's only one intersection, right? Think about, when does a quadratic only have one solution, right? And the answer to that question is it's when specifically the discriminant is equal to 0, right? So you set the discriminant equal to 0. Now, whenever you're dealing with like finding a discriminant, right, you never really want negatives in your first term here. So I'm going to multiply by -1. So then this will become this, right? And let's apply the discriminant, right? B squared minus 4ac. So you have p minus 7 squared minus 4 times a, and then c is 18. And then this all equals 0, right? Now you have p minus 7 squared equals 144, right? And then you have p minus 7 equals plus minus, right? Don't forget that plus minus when you're taking the square root. So the two values for p are 19 and -5, right? Now, we know the value of p, right? That makes the intersection at only one point, right? Makes these systems intersect at only one point. How do you actually find the x-coordinate? Well, to do this, I first have to explain to you a specific concept, right? It has to do with the discriminant, right? Usually, a lot of times, we say that when the discriminant is equal to 0, there's only one solution, right? You might be wondering, like, why is that the case? Well, say you have a xy plane, right? You have a parabola, and right, by one solution, it means that it only intersects the x-axis once. Now, why does the discriminant have to be equal to 0? Well, here's why, right? You might recall, right, to find that intersection point for a quadratic equation, you use a quadratic formula, which is -b plus or minus square root of b squared minus 4ac over 2a, right? You should have that memorized by now, right, if you're taking this SAT. But now, the reason why, right, there's only one specific solution when the discriminant is equal to 0 is because, well, if you look at this, right, formula here, if you set this part, right, again, b squared minus 4ac, that's a discriminant. If you set that equal to 0, you get square root of 0, right? Well, the square root of 0 is just 0. All of this goes out, right? So you don't need that plus or minus because, well, if you're adding plus or minus 0, that's not going to change the value of x, right? So you have essentially this, right, -b over 2a. That gives you the solution for x, right? So why is this important for this problem? Well, because if you're trying to find the x value, right? Well, the x value is literally right here, right? It's negative b over 2a, right? When the intersection, there's only one intersection, right? When there's only one solution, right? So effectively, or essentially, you're just trying to find the value of negative b over 2a, right? How do you do that? Well, go back to this initial equation that we had, right? We're trying to find negative b over 2a, right? Well, let's plug that in, right? So you have negative p minus 7, 2 times a is 4, so you'd get that. So we're actually almost at our answer here, right? Remember how we had two values for p, 19 and negative 5, right? So let's plug those in. So the first one, right, you have 19 minus 7 over 4. That gives you negative 3, right? And then you have negative 19. What was the other? Okay, so you have negative 5, right? Minus negative 5 over 4, right? That gives you negative 19 plus 5, which is 24. Right? So you have, again, and you don't actually need to find the second solution here, but you have negative 19 minus negative 5 over 4, right? That's the second value for x, and this is the first value for x. Well, you'll realize our first value here, negative 3, well, that means that literally matches answer choice C here, right? So you can circle that answer, and that's going to give you a point, right? But the other way to do this, right, you can use Desmos, right? So if you type in y equals negative 2x squared, and I'm just going to type in the other one, right? What you'll notice is, well, if you just play around with this value of p, right, make a bigger range for p, right, so it gives you more opportunities to get the solution, but you'll notice that if you play around with p, right, you're trying to find where it has 1 point as a solution. So just change the value of p until you see these two systems or these two graphs only intersect at 1 point, right? So the first one, right, negative 5 here, right? You'll notice, and you can also just type it in, right? You'll notice that if you click on that intersection point, it's at x equals 3, comma negative 47, right? And if you once again change the slider and go all the way to like p equals 19, right? You'll notice that the intersection point is at x equals negative 3, comma negative 89. And we got negative 3 as an answer choice here, right? So yeah, that's another way you can just play around with the value with a slider and see where the graphs intersect at 1 point, and then you can tap on the x coordinate. You can tap on the intersection point and look at the x coordinate. But in my opinion, this method is actually worse to use on the SAT because, right? Think about it. You don't like if you use this Desmos method first, you don't know what the value of p actually is, right? So you're gonna have to experiment a lot, and that wastes a lot of time. So I'd rather take this mathematical approach, right? Um, and just to kind of recap, right? What you do is you effectively, or you essentially find a discriminant, right? You set it equal to 0, and that gives you the value of p. And then what you realize is that that x coordinate that you're looking for is just negative b over 2a, right? So you find negative b over 2a, which gives you the x coordinate, right? And that gives you the right answer. So hopefully that entire method there made sense. But of course, if you have any questions, leave it down in the comments. Make sure you hit the like and subscribe. And we post videos daily to help you guys on your SAT and ACT prep. So if you want to be notified when our new videos come out, right, just hit that notification bell. But thanks for listening, and I'll see you next time.